All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing. I'm trying to remember if I started learning PyTorch during one of my talking streams or not. I don't think so. I did mention that I wanted to get into it. Give me a second. I forgot to transition just to get rid of the mute text because earlier I was doing a mute stream. But yeah, I don't think I did a talking stream where I was learning PyTorch. So we're gonna be learning more PyTorch stuff because I started learning PyTorch yesterday, or well, I officially got into it. I officially started learning it. In the past, I've kind of just kind of like touched it here and there, and then not really done much with it. But this time, I'm hopefully gonna get much more deeper into PyTorch and not just touch it and forget about it after some time. So I started yesterday, and well, another good news is that I also started doing the mute study streams again. So it's one of those things where like when I'm when I'm doing some kind of study thing, I'll just start up the stream. It'll be a mute stream, but like I kind of want to do that. I kind of want to I kind of want to do like a mix of mute and talking study streams. Cuz like I mean, this is also a study stream, but in this stream I'm talking. In the other one I'm not. It's just mute. And those actually run a little longer as well, a little longer than my usual streams. One of the reasons is because those streams are way more laid back than these streams. I mean, to be honest, even these streams are kind of laid back because like that's just how I do my study streams. But those streams are even more laid back. Okay, all that being said, I have started learning PyTorch, and we have fortunately I started learning it on stream. We looked into a couple of different things. Right now we are on this data sets and data loaders section. The tutorial, or well, the tutorial section has a couple of like subsections. It's divided into multiple sections. In the quick start section, it kind of runs you through the process of making a neural network from the start to finish. It teaches you how to load a data set and then build a neural network and then train the neural network and finally, use the neural network, which is great. Like it runs you through that entire process, especially when it comes to, because like each of these steps, it has like a bunch of steps within it. So like with building the neural network, you have to define a class that's gonna describe the architecture of your network, right? And then with training, you have this thing of running the neural network and seeing how do I say this? Running the neural network and calculating your loss, calculating the error, and then based on that error, you're going to change your values and then run it again, and then calculate the error and then change the values and run it again and again and again. That's the whole process of training, basically. But like I'm simplifying it. Within the training process, there's a couple of other things that you have to do. So it kind of the whole idea with the quick start section. Actually, let me just open that up. Give it a second. It's gonna take a little bit. But yeah, I'm happy that I have started doing the mute streams again, and hopefully this time I'm gonna stick with it. I want to do like a mixture of mute streams and talking streams. At some point, I do want to get into. I want to explore Twitch IO, which is a Twitch library for Python. There's a bunch of different things that you can do with it, and I want to explore all of those things because so far I've used Twitch lib, but Twitch lib is for C sharp, and it's great. Like I've done a bunch of things with it. But I also want to explore the Python side of things. Okay, so this page is loaded. So here, this is divided into a couple of sections. First, you load the data set, or well, first you download the data set, then you load the data set using their data loader. Then you create your model. This is where you define your neural network's architecture. You define it in a class. And then you I think this is the section where this is basically part of the training because it's saying optimizing the model parameters and calculating a loss function because like the loss function is that's what you use for training then, right? And then yeah, here well, so yeah, this is part of the training basically. And then what was next? There was another thing. Oh yeah, I forgot about this. So here they show you how to save your model, and I want to look into this because like this is definitely some useful knowledge to have. Saving and loading models in not just PyTorch but also in Onyx. I want to look into the Onyx format because it's a fairly well known and I would say a pretty widely adopted format. Fortunately, it's open source, at least from what I know. So yeah, I want to look into that as well. So yeah, they teach you how to do the saving and loading and yeah, that's the end of the quick start section. So basically what I was trying to explain was that the quick start section, it runs you through the process of loading the data, defining the network architecture, running the network, training the network, and then also something that I forgot to mention, but it's shown here, is saving and loading the model. And after that, it kind of goes into more detail. So all of that gets split up into multiple different sections, which if this will cooperate with me, I can show you. Where is it? Why is it not showing up? All right, for some reason it's not showing up here, but whatever. Yeah, so then we can go into all of the other individual sections where you have this thing where it explains tensors and then data sets and data loaders, then transforms, then building the model. Then I think autograd and optimization are part of the training process, but like don't quote me on that. We're gonna have to explore that more. I can't say for sure. And then of course saving and loading the model. So quick start, it runs you through the process quickly, just so you can kind of see the whole thing in action, the whole thing happening. And then later on you can like later on it kind of like explains every single section in much more detail. And I've kind of been like jumping between these things. So like I was in the quick start section. Oh god, my system, dude. My system is chugging. Okay. So I was in the quick start section and I reached up to this part, I believe. Yeah, I stopped here. So I just built the I just built the neural network. I didn't run the neural network. I just built it. And then I kind of got distracted with a bunch of other things and I just ran with it. Like it works for me. I'll come back to this eventually. Um, so what I did is wait, I'm curious. Why is it not showing the fucking like the links and oh god, dude, this is so slow right now. Okay, maybe it's just a matter of oh, oh, it wasn't showing it here because this is something else. This is not the thing. This is the this is a this is a page that mentions all the data sets. This is not part of the tutorial. This is something else. Okay, that's my bad. Okay, so I ended up getting distracted and I jumped to tensors, which I was happy about because I took my own. I usually just take my own, you know, my own path, and in this case, that meant just sort of interrupting the quick start tutorial and jumping into tensors. Once I finish tensors, now I'm looking at data sets and data loaders. In this section, I've finished the data sets part, but I'm looking at the data loaders part now. And after that, I think the next section is transforms. So we're going to look into that as well. And yeah, we're just gonna take this one section at a time. We're gonna learn this bit by bit, and gradually, I'm gonna learn how to build and train my own neural network. For now, I'm sticking with feed forward neural networks because that's like the simplest form that you can create, the simplest kind of neural network you can create. Then you have more complex neural networks like recurrent neural networks and convolutional neural networks and probably other types of neural networks as well. For the time being, I just want to stick with a feed-forward neural network. So what I'm doing is I'm kind of learning from multiple sources. Right now, I'm learning PyTorch, but I'm also watching the MIT lecture videos because MIT has a course on deep learning. And oh, you know what? I should bring it up. I mean, I brought it up during one of my previous talking streams. Um, hold on, give me a second. Let me just load that up. I did bring it up during one of my previous streams, but I feel like I should bring it up. I feel like I should bring it up and like show people every stream, just so anyone else, or at least every stream where I'm learning, where I'm doing deep learning stuff, because at least that way, like anyone else who's interested in learning deep learning, maybe they could benefit from. Actually, not maybe. I think you could definitely benefit from watching these videos, especially if you're like a beginner in deep learning and even machine learning for that matter. I feel like you can benefit from watching these videos if you're like if y- I think even if you don't know anything about machine learning, these videos they kind of teach you in a way that you don't necessarily need to know machine learning. There's still a bunch of math that you would need to know, but not knowing it is not going to be like it's not going to be like a complete deal breaker for you. Let me just put it in that way. Like if there's something that you see and you don't really understand the math behind it, it doesn't mean that you're not going to be able to proceed with it. It doesn't mean you're not going to be able to make any progress with it. Understand that a lot of the math that's involved with these things, there's going to be very few situations where you have to do the math manually, where you have to do the math yourself. Generally, you don't need to do the math yourself. There are functions provided for it, and especially if you're doing it in Python, for example, you are most definitely going to have libraries at your disposal and functions at your disposal to do a bunch of this work for you. Give me give me a second. I have hold on, dude. What is going on? I need to like get to the bottom of this. For some reason, during my talking streams, every now and then it happens that my voice just kind of starts shaking and I don't even realize like why it's happening. I know that it's happening, but it's like I don't know what's I mean, now it's much better. Now that I said it. Now that I'm like, yo, what's up, Sama? Welcome to the stream. Hello, hello. We are learning PyTorch. We are learning about neural networks, and we are doing deep learning stuff. I was gonna load something up. So MIT deep learning. Here it is. Let me just open up this thing and we are good to go. Okay. So let that load up. So anyone else who is interested in learning deep learning, head over to this website. Actually, you don't even need to head over to. I mean, it'll help if you head over to the website because there's a bunch of the other stuff here as well. But you could just start with this. You could open up YouTube, and on YouTube you can type in this video name. Give give this thing a second. My connection is shit. My system's performance is shit right now. Just give it a second. Why am I not scared? I don't know. I'm too distracted. My mind is too busy to be scared, dude. Right. So, this is the video. Look up look up MIT Introduction to Deep Learning, and you want to look for the 2024 version. It'll mention in the description new 2024 edition. And there's an entire playlist of this. This playlist has 71 videos, but you don't have to watch all 71 videos. The 2024 thing, I like that they've set different colors here, so we can kind of differentiate between them. So you have probably 8 videos to watch, but you don't have to watch all of them at once. You can start with the very first one. The very first one, it introduces you to deep learning and then explores various neural network related, like it teaches you the basics of neural networks, and then it goes into feed forward neural networks, which are which that's kind of like the most basic neural networks that you can get. It goes into the basics of feed forward neural networks, and it explains how they work, all the different working parts of it, and how you can train them, and what is the process of training, throughout the process of training, what calculations you have to do, all of that stuff. It goes into all of those details. So what you can do is you can watch the first lecture, and then you can try and do it. You can try and practice it in PyTorch or in TensorFlow, depending on what you are using. And the good news is they have like a labs thing here. So the way that they have structured this course is you have one lecture and then another lecture and then a lab and then another lecture and another lecture and then a lab. So I mean, you can follow that if you want, or you can do it in your own way. I'm doing it in my own way. I'll follow their lab as well, but like I'm kind of just doing it in my own way. I'm learning it in my own way. Damn it, Abhi! It is Friday the 13th, and I want to be scary. You can be scary if you want, though. That's an interesting point. I didn't notice that it's Friday the 13th. Somehow that didn't occur to me. Mom was asking, what's the day today? And I was like, I didn't know what date it was. So I looked at the calendar and I was like, okay, so it could either be Thursday or Friday, depending on whether it's the 12th or the 13th today. And she said it's Friday. somehow it didn't click that yeah, today's Friday the 13th. Yeah, maybe I should watch nah, I don't feel like watching. I don't feel like watching that. Speaking of, so I was gonna say just as a dumb joke that maybe I should watch Friday the 13th or whatever the Michael Myers movie is called because it's on Netflix, so I could watch that. But I'm like, nah, I don't feel like watching that. At the moment, I'm watching this dark comedy series called what is it? What's the name? It's called Santa Clarita Diet. Yeah, or Santa Clarita, however they pronounce it. Um, yeah, it's called Santa Clarita Diet, and it's a dude. It's a dark comedy series. I've been enjoying it. I'm pretty much at the end. I'm on season 3, and it's one of those series where each episode is like half an hour long, so I was able to run through it pretty quickly. It was great because I was doing my mute stream and I was watching the series on the side. But yeah, okay, let's carry on with this. Give me a second. Let me hydrate first, and then we'll carry on with loading the data set. Okay, all right. So, earlier I was trying to I was exploring various aspects of the data set itself because as an example, you can load one of the fashion MNIST website, no, not website, data sets that's available for free. And they have a couple of different example data sets available that you can use for for practice purposes. So I was looking into this fashion data set, and I was trying to understand various aspects of it, and I had a bit of a confusion about where exactly the files were. It didn't occur to me that the entire data is kind of serialized into like specific files. It's not like there's going to be individual files, even though the data is referring to multiple files, but like all of that data has been serialized into like one object kind of thing. It's been serialized into like a binary format, basically. All right. So, I was at, I finished the data set part. Now I have to look into the data loading part. So, preparing your data for training with data loaders. So, the dataset retrieves our dataset's features and labels one sample at a time. While training a model, we typically want to pass samples in mini batches. Oh, wait, Sama, you said something. Uh, Only scary people like me notice. Yeah, probably. Probably. I think Halloween is coming up, isn't it? Yeah, I think this is the month for Halloween. Hold on. Let me just Google that. Okay, no, scratch that. It is not coming up. It's like a month and a half away. It is on October 31st. Okay. All right. So, carrying on, while training a model, we typically want to pass samples in mini batches. Give me a second. Okay, where was I? Yeah, we typically want to pass samples in mini batches, reshuffle the data at every epoch to reduce model overfitting. Reshuffle the data at every epoch to reduce model overfitting, and use Python's multiprocessing to speed up data retrieval. Okay, at every epoch. So each epoch is one training iteration, if I remember right. I believe so. So okay, we are training. Okay, that's interesting. So sorry about that. I hit my mic somehow. Yeah. So okay, it says wait, back up. Reshuffle the data at every epoch. So we typically want to pass samples in mini batches. So we are training the neural network on batches of data at a time, not the entire data. Is that what's happening? Like, am I understanding that right? And it says reshuffle the data at every epoch to reduce model overfitting. Okay. Uh, I feel like I'm gonna need to do this practically to understand what exactly this means. Because like I'm having trouble I'm having trouble kind of visualizing what would be happening. Um, because like it says we reshuffle the data at every epoch, but um it also says that we typically want to pass samples in mini batches. So each time we are training it on no, I'm not getting this. I'm not getting this because like I'm trying to imagine it. Like, okay, if we are passing it a specific batch of data, we pass it a specific batch of data, right? And then we run the model, and then we use the loss function to calculate our error, and then we compare that error against some kind of average of this batch of data that we passed it. And then in the next iteration, we reshuffle the data, get another batch of data, and then run the same process again where we run the model, we calculate the error, and then compare that against an average. Because I mean, it would have to be an average of some sort, right? Because what if the batch that we have loaded doesn't contain the specific thing that was meant to be predicted? This is interesting, dude. Okay, so there's a lot that I can learn here. There's a lot to explore here. This is going to be oh shit, I missed the ad timer. Okay, so there's going to be an ad playing in a little bit. I'd say a couple of seconds now. But yeah, let's carry on reading this, because like, okay, we are now we're going to be loading the data. Then there's a transforms section, so we're going to look into transforms as well. What exactly does this cover? Data does not Data does not always come in its final processed form that is required for training machine learning algorithms. We use transforms to perform some manipulation of the data and make it suitable for training. All right, so we're gonna look into that as well. Oh wow, okay, this is a pretty short section. This is not that big. Okay, 2tensor converts a PIL image. Oh, PIL. Okay, by the way, there's an ad playing right now, so I don't know. I'll see you guys in 30 seconds. All right, welcome back. You know, you know what I realized? So I say I'll see you guys in 30 seconds, but usually by the time I get to that point where I'm saying I'll see you guys in 30 seconds, the 30-second ad is probably already 10 seconds in, meaning it's not going to be 30 seconds. I'm going to take a break for another 20 seconds and then resume again. So I say I'll see you guys in 30 seconds, but like it's not really 30 seconds. Okay, anyways. So speaking of PIL, I need to explore the PIL library as well. Fortunately, I don't need to install it, though it's not like installing it would be a huge headache. It's a minor convenient voice crack. Holy shit. It's a minor convenience. It's a minor convenience that PIL is already installed as part of PyTorch. I think it's one of the dependencies. Okay. So yeah, I need to look into PIL as well. Right. There isn't too much to look at in this section, so I feel like we're gonna go through this fairly quick. But it does mention something about this. So the features are in PIL image format and the labels are integers. Yeah, I noticed that the labels are integers and we are able to access, I believe those integers are, actually there's a dictionary as well. So they have like a, give me a second. I can show it here rather than explaining. Okay. Where was I? Yeah. So training data dot, they have a classes property slash field, and they also have a classes to indices. I think that's a dictionary. And that actually prints out a dictionary where you have the class name as a key. The classes are basically the labels. Well, the classes are basically the categories. I don't know if calling them labels here would necessarily be an accurate thing or not. Why is this taking so long? Okay, let's just wait for it to do its thing. Oh, actually, you guys can't see it because the bottom of this thing is cut off. It's saying it's analyzing the cells, and usually when that happens, then IntelliSense takes some time. Let's try again. Oh, there it is. Great. So classes. Oh, it's slowly loading. Now it's done loading. Great. Awesome. Give this a couple of seconds, and yeah, here it is. So this is the list of the classes. These are basically the categories of the images, right? And these classes also have associated indices, and those indices are what are stored in the data set, which is great. That's actually much better than storing just the text. I mean, the text obviously has to be stored as well, but like in terms of storing it in a data structure, I feel like storing the number is a lot more helpful. Or well, what's the word I'm trying to use here? Not optimized. It makes it easier to work with that data as opposed to the actual text itself. Okay, what was I gonna do? I think it was class to index. So this dictionary mentions uh, the indices for each of the classes. The indices are what are stored in the data set. So let's say I try to access this. So if I try to access the first row out of the 60,000 rows that we have, give it a second. So this thing has um, two cells, I guess you can say. One of them is the image itself, and the other is the class that it belongs to. I don't know if yeah, the class is mentioned here. So this one says 9. So there's two elements to this cell. One of them is the image data, and the other is the class or the label. Give me a second. Let me just fix the music situation, and then we can carry on. Okay, right. So okay, preparing your data for training with data loaders. Okay, okay. Oh yeah, this was where I kind of like just got distracted. I need to experiment. There's a lot to experiment with here. So um I'm kind of excited to kind of like dive into this. I feel like the questions that I have are not really going to be answered right now. They're going to be answered once I actually start training the neural network, and like in building the neural network as well, I have a bunch of different questions, mostly relating to how defining the architecture is working, how the process of defining the architecture works in PyTorch. Because if you look at the quick start section, actually, you know what? The build model section might the build model section might. Oh God, dude, this scroll thing. If you see the page just randomly scrolling, unless you see this, unless you see this icon, actually, is this showing? I think this might be showing up. Give me a second. Let me just. No, I don't think you are able to see that either. So okay, I have like an auto scroll thing going on. It's one of those things where like you press the middle mouse button on a web page, and then you're able to like move your mouse up and down to scroll. Usually that's what I use to scroll because the wheels on my mice usually go bad pretty quick, and what ends up happening is because the wheel is malfunctioning, so it'll randomly scroll the page, and that's been happening quite a bit recently. Anyways, give me a second. All right. Okay, so if we look at the quick start section, and I think my question might get answered, my question regarding how the process of defining the architecture is really working in PyTorch, I feel like that question is going to get answered in this section because this section actually goes into full detail with it. I'm hoping it goes into full detail with it. To use the model, we pass input data. Okay, okay. No. I'm. Oh, yeah. Let's break down the layers in so and so. We initialize this. Okay, okay, okay. So and so is a module that applies a linear transformation on the input using the stored. Okay. Uh, I don't know if this is going to. It might. It might. You know what? It might. It might answer my question because yeah, it just occurred to me after seeing this. Actually, well, not this necessarily, but this. After seeing this, it occurred to me that I could have been calling these functions separately as well. I didn't necessarily need to. I didn't necessarily need to call them within the class. Like during while defining the neural network's architecture, I didn't need to only do it at that time. Or I should say I wasn't limited to only doing it at that time. I could have just called the functions like by themselves. The thing is, I get a feeling that there's internal variables that are being changed or that are being set in order for these different functions to work. There are internal variables that are being set that I don't know about. And that is what I'm trying to understand, what the inner workings are, because this, like the way that this is defined, it didn't really tell me much. Let me show you where it is. Actually, okay, I don't need to show it in my code. I can just show here. The way that the neural network was defined, it didn't tell me a whole lot. Like here we had like this thing where we defined a linear stack. I know that this is a sequential thing, but within the sequential thing, we are passing each of these things. So it didn't really explain what is going on here. But I guess that's why I need to explore this more to understand exactly what's going on with this setup. Like even this simple thing, this simple block, I need to understand exactly what is going on here. So there's a couple of things to explore. And these are all like basic things right now. We are still looking at what I'm assuming is a feed forward neural network. It's not something more complex. We're going to look into more complex stuff later on. I don't know if the tutorial goes into actually this is a basics tutorial, right? There's more complex stuff as well. They have like an entire section on, or well, not an entire sec. They have like new tutorials on various things. Um, where is that? What should I be looking at? Okay, so I mean, there's probably multiple sections here that I could look into for various types of. Uh, yeah, yeah. There's probably different types of tutorials that are different. I'm losing my words. My mind is all over the place. There are probably multiple sections that I can look into, uh, where I'll find various types of tutorials for various various different types of neural networks. Uh, Hold on, let's take a look at what's happening here. More specifically, I'm interested in the neural network. So let's look at, okay, okay, okay. So I'm seeing convnet mentioned here, so I'm assuming it's a convolutional neural network. In this tutorial, we'll be using a mask RCNN, okay, which is based on top of faster RCNN. Okay, this is interesting, dude. So yeah, I need to. Okay, hold on. I'm curious. Does PyTorch implement these things for you, or like would you have to do your own implementation? Uh oh, it's already implemented here. Faster RCNN. All right, so there's a bunch of like more advanced stuff that we need to get into after going into the basics. So the good news is that there's going to be a bunch of information for us because there's like tons and tons of tutorials on this website alone. There's tons of tutorials that we can look at for various purposes. Okay, what is this looking into? Spatial transformer networks. In this tutorial, you will learn how to augment your network using a visual attention mechanism called spatial transformer networks. You can read more about the spatial transformer networks in the DeepMind paper. Okay. Okay, so something I'll need to keep in mind is I need to try and visualize these networks, at least to whatever extent it's possible. Now, with simpler neural networks, it'll be easier to visualize, but I feel like when we start going into more complex models, like more, well, networks and models that actually do something useful, I feel like those models actually get more complex in their design. I don't know to what extent visualizing them using an existing tool is possible. Um, because like I want to try and use something like NNSVG, but that's I feel like the use of that is gonna stop at a certain point. I don't know what that point is, or I should say I feel like the usefulness of it uh, is gonna stop at a certain point, and at that point I'm gonna need to find other tools that are able to do this. There are other libraries that I can use where I can properly define a much more complex network using coding, and then the system will generate the code based on what I've defined, and it's going to draw out the entire neural network in that way. I'm going to have to see to what extent doing these kinds of diagrams is possible. There's this, and then there was another one which was something like this. I mean, I'm definitely not expecting this kind of thing, but like these kinds of things, I don't know to what extent that would be possible. Because like some of this stuff can be done, like NNSVG can do a fair bit of stuff, depending on like what kind of network architecture you're going for. But I'm gonna have to find out what the limit is with it, and once I hit that limit, I'm gonna need to find other ways to visualize the network as well, because I feel like if I'm not visualizing the network, i'm going to get I'm going to get confused. Okay, anyways, this was a fun distraction. I want to explore more of the tutorials in this section. This is on YouTube. I'm looking for the tutorials in this. Okay, learning PyTorch, deep learning, a 60-minute blitz. Okay, let's take a look at this. Okay, I didn't I don't know what blitz is supposed to mean here, so I wasn't sure what I was getting into when I clicked this, but I feel like I'm going to be doing whatever this is going through. I feel like I'm going to be doing that. Oh, wait, no. Nope. Hold on. To run the tutorials below, make sure you have so and so. Okay. All right. Great. So next it goes into tensors. All right. So this is then what divided into 4 sections, I think. Okay. All right. Wait, no, this is holy shit. This is going into like a good good amount of detail. Holy shit, dude. Why wasn't I looking at this before? I should probably be looking at. No, you know what? It's a good thing I didn't look into this, because this goes into it's a good thing. It goes into a lot of detail. Um, Now, you know what? I should have. Well, I mean, to be fair, I would have gotten to it eventually. Um, Wait, so they have a tutorial section, right? Let's just open that up. Let's also zoom out because I feel like, because like I've zoomed into this just so I can see, because like my monitor is far away from me, so just to be able to see all the text, I have to like zoom in. So let's zoom out so I can properly see the website. And yeah, okay. All right. There's learn the basics. Then there's PyTorch recipes. Introduction to PyTorch on YouTube. Learn the basics. Learn the basics is what I'm in right now. Then there's learn PyTorch by examples. Then there's what is Py. Holy shit, dude! I haven't looked into all of this. Visualizing models, data, and training with TensorBoard. I've never heard of TensorBoard. So let's take a look at that. Good usage of non-blocking and pin memory. Okay, so what I had looked into was this section. And this was, okay, deep learning and then learning PyTorch with example. Wait, so what did I just open up? What exactly is learning the basics? Like, is that like this, what I'm in right now? Or was it the 60-minute blitz thing? No, it's this one. Okay. Okay. Then we have learn PyTorch with examples. Okay, so these are all, I think these are all different tutorials made by like different groups of people. Okay, what is Torch N really? We recommend running this tutorial as a notebook, not a script. Download the notebook and so on. So, okay. Neural net from scratch. Let's first create a model using nothing but PyTorch tensor operations. Oh, that's, dude. Okay. Yeah, I wanna do that. I wanna do that. Yeah, because I feel like doing it from scratch can teach you a lot. That being said, you don't always have to do it from scratch. Um, there's a reason why these libraries exist. You don't always have to do it from scratch because libraries like PyTorch and TensorFlow, they can do it for you. However, doing it from scratch can teach you quite a bit. Okay, we can now run a training loop, which again, even over here, so they're selecting a small batch of the data. It's not the entire data. So they're selecting a small batch of the data, then they make a prediction with the model, and then they calculate the loss. The I'm just guessing that the loss is being compared to this batch of data, not to the entire data. Because like this is the batch of data that's being like loaded, right? So I'm guessing they're comparing it to this. And I think that is also why they have to do a shuffle. Oh, I think keeping the data size small makes the size of the neural network small. Because if they loaded the entire batch of data at once, they would probably need a much bigger neural network. Yeah, I think so. I think that might be the reason. Though I can't say for sure. Also, another reason why they might be keeping the batches of data small is because of hardware limitations. Because, like, I think offloading it to the GPU, um, well, I mean, to be fair, even doing it on the CPU, you would need to worry about memory stuff. Like, just yesterday, when I was trying to do a calculation, I think it was on the GPU or on the CPU. I can't remember. It it straight up just gave me an error saying, out of memory. And then there was another instance where I purposely made a tensor massive and tried to do an operation on it just to see how long that would take, and I ended up crashing the entire stream. That was the end of the stream, basically. And then fortunately, I waited, and fortunately it finished doing the calculation, and then my system kind of returned back to normal. But yeah, that was something. Okay, so this is also a section that I can go through. And then there's this visualizing models, data, and training with TensorBoard. Oh, yeah, here it is. In the 60-minute blitz, we show you how to load in data, feed it through a model we define as a subclass of so and so, train this model on training data, and test it on test data. To see what's happening, we print out statistics as the model is training to get a sense of whether training is progressing. However, we can do a much however fuck's sake, let me zoom in. Hold on. Okay, where was I? To see what's happening, we print out some stats. That word is so fucking hard. Statistics. Holy shit, dude. Some stats as the model is training to get a sense of whether training is progressing. However, we can do much better than that. PyTorch integrates with TensorBoard, a tool designed for visualizing of neural networks, the results of neural network training runs. This tutorial illustrates some of its functionality using the Fashion MNIST dataset, which can be read into PyTorch using so and so. Okay. Okay, so this is something I'm interested in. Inspecting the model's architecture using TensorBoard. I want to see what TensorBoard is actually. Like, is this a separate platform, or is it like a library, or now we'll set up TensorBoard, importing TensorBoard from so and so. Okay, so for one thing, it's a library. All right. Writing to TensorBoard. Wait, hold up. How did we get here? From the command line, and then navigating to so and so. So this is some kind of like this allows us to launch some kind of server that's going to launch all of this stuff in it. Where exactly do we do that? Writing to TensorBoard. Now let's write our image to TensorBoard specifically using so and so. Okay. Okay, I need to do some research on TensorBoard and how it works and what we are supposed to do in it. However, this is good to know. All right, so it gives you a kind of graph Um, hold on, dude. What? Wait a minute. Okay, so I need to look into TensorBoard and I need to look into TensorBoard alternatives as well. Like if there's something that can do a similar set of things that this platform is able to do. Tracking model training with TensorBoard. Dude, there's so much that I'm learning here. Holy shit. I need to go through these I need to go through this entire like tutorial section a lot more often. But I'm glad that this was covered over here in this section, like learning the basics, because this is kind of important. Okay, how many more pages do we have? Okay, so let's go to the second page and see what's there. On the second page, we have Torch Vision Object Detection Fine-Tuning Tutorial. Okay, Transfer Learning for Computer Vision Tutorial. Optimizing Vision Transformer Model. Adversarial Example Generation. Training a convolutional neural network for image classification using transfer learning. Okay. Oh, dude, there's like a bunch of pretty, weird as it may sound, juicy examples. There's a bunch of like pretty juicy examples here. Tutorials, in fact, juicy tutorials. I feel like if I go through a bunch of these, I'm gonna learn like so much, and it's gonna make me, oh holy shit, dude. I've been meaning to look into this. So Wave to Vec, from what I understand, is it's a work by Meta. It's an open source model released by Meta. Let me just confirm that so I'm not accidentally giving, because I believe it's done. Yeah, it's by a team working at the Facebook AI lab. Give me a second. Uh, Wave to Vec. Yeah, yeah. So this is by Meta, and I think this is integrated into PyTorch as well. I could be wrong. I'm not sure. I think it's integrated into Hugging Face transformers. I don't know if it's integrated here. There are pre-trained there are multiple pre-trained models available in Torch Audio.pipelines. Okay. All right. So Wave to Vec might be one of them. But this is great. Like this is something that I'd been meaning to look into, because this will help with creating a speech to text model, which is something that I've been meaning to look into for myself. So this should be fun once I've gotten more comfortable with PyTorch, and once I know more about deep learning, because there's still like tons of stuff for me to learn. And fortunately, there's tons of tutorials for me to follow. All right, what more do we have? Speech command classification, text to speech as well. Great, cool. That's also something that I'd been meaning to look into. Why is this not scrolling, dude? Okay, whatever. Force alignment. I'm not sure what that's all about. Um, Fast transformer inference with better transformer. NLP from scratch, classifying names with a character level recurrent neural network. NLP from scratch. I'm interested in that. I'm definitely interested in that. Because I've mentioned before that NLP is something that I also want to look into, and like I want to learn it from I want to learn it from scratch because I want to get into building LLMs at some point. But NLP is kind of a it's kind of like a prerequisite of that because there's like tons of NLP related concepts that go into building an LLM. Of course, you could also just use pre-made stuff, but to a certain extent, I do want to know, I do want to learn about the concepts. I don't want to implement every single thing from scratch, but I do want to learn NLP related concepts. I'm still going to be using a bunch of libraries to accomplish what I'm trying to accomplish. But even given that, it's important to learn the concepts, like how right now I'm looking into right now through the tutorial I'm building feed forward neural networks, right? I'm building a feed forward neural network. But the only reason I know that this is a feed forward neural network, and actually, you know what? I've been assuming that this is a feed forward neural network. Because I mean that makes sense, doesn't it? Like that's my assumption that when I look at this, where is it? When I look at this, this is my assumption that we we have the input and then an activation function, and then this is a hidden layer. This is an activation function, and I'm assuming this is the output layer. I'm just assuming. I don't know. That just occurred to me that my assumption could be wrong. That this is a feed forward feed. My assumption could be wrong that this is a feed forward neural network. A bunch of these terms are just not easy for me to pronounce. Motherfucker, dude. This is so. I mean, to be fair, it's also getting kind of hard for me to talk. So my that's why I'm having trouble pronouncing fuck's sake, dude. Pronouncing things. I just mixed up things and stuff. Came out as thuff. Wow. Okay. Uh what's going on here? Oh, yeah. Okay. Yes, I was looking at this. NLP from scratch. We will we will be building a basic character level recurrent neural network to classify words. This this tutorial along with two other NLP from scratch tutorials, okay, show how to pre-process data to model NLP. In particular, these tutorials do not use many of the convenience functions of Torch text, so you can see how pre-processing to model NLP works at a lower level. Okay, hell yeah. All right. Dude, yeah, I'm wondering if I'm wrong about this. I'm wondering if I was wrong about this. I guess I'm gonna need to properly understand. So I'm gonna stop calling this a feed forward neural network now. Um, you know what? For the sake of satisfying my curiosity, let me ask Gemini whether this would be considered a feed-forward neural network, because I don't know exactly what's going on in this to be able to say that it's a feed-forward neural network. Okay. Let me say this. Okay, in the following code, would you call this a feed-forward neural network? Or some other kind of network? Okay, self.linear underscore relu stack equals nn.sequential okay nn.linear let's say 5 and then 512, or I mean we can keep it small, so let's say 32, right? And then nn.relu, all right. Then nn.linear, let's say 10, 64, okay. Then nn.relu, and then nn.linear, let's say, I don't know, 3 and 8. Yes, the code you provided represents a feed-forward neural network. A feed-forward neural network is characterized by linear layers. These layers perform linear transformations on input data, multiplying it by a weight matrix and adding a bias vector, activation function, which is the ReLU, and then sequential structure. The layers are connected sequentially with the output of one layer serving as the input to the next. The specific structure of your neural network is as follows: input layer, hidden layer again, and then output layer. Oh, okay, hold on. That's interesting. So in this code, apparently, based on what this thing is saying, this is the input. And then that goes into this, which is the hidden layer, I think. No, wait. What values did I give this? I said 5 and 32. Is that what I said? Yeah, I said 5 and then 32. So that second value apparently goes to the hidden layer. The first value is the input. The second value goes to the hidden layer. And then there's an activation function. And then there's another input. Okay, let's take a look at what it says about the second input. So the second input says 64. All right, okay. Okay. Glad that I cleared that up. I feel a little bit better now about having not made the wrong assumption that this was a feed-forward neural network. Great. How did I get to this point? Okay, I don't remember, so we're just gonna carry on looking at more examples. Okay, text classification with torch text. Learn how to build the dataset and classify text using torch text library. Language translation with transformer. Preprocess custom text dataset with Torch text. Exporting a PyTorch model to Onyx using Torch Dynamo backend and running it using Onyx runtime. This is something I need to look into. I definitely want to learn about the Onyx format and how to export a PyTorch model to the Onyx format and then run it in the Onyx format itself. Because from what I understand, Onyx has its own runtime as well. All right, cool, cool. So we are going to go back to page 1. Where's page 1? Okay, so where was I? I think I was in this. I don't remember what exactly led to the distraction, but I'm glad that I got distracted with it because there's clearly a lot more for me to look into, not just this one small section. This one small section is going to teach me the basics, which I absolutely need. I'm going to need these basics in order to be able to go and do more advanced stuff. So, yeah, I'm glad I looked into this because okay, with the more advanced stuff, before looking into the advanced stuff, I'm gonna need to rewatch some of those other MIT lecture videos. Actually, in some of them, it's not even gonna be rewatching. Some of them I haven't watched yet, like at all, because I remember watching the recurrent neural network one. I believe that also mentioned transforms, or well, no, it mentioned transformers. Yeah, it mentioned the concept of transformers. And then I watched the convolutional neural network one. And then there was one more that I'd watched, which I don't fully remember what it was. But yeah, there's a bunch of other videos as well to watch. So yeah, just taking it bit by bit. Let's let's learn all of this bit by bit. Okay, so where was I here? I think I was in this section, the data loaders section. All right, so iterate through the data loader. We have loaded the data set into the data loader and can wait, have we done that? Yeah, we've done that here. I need to do that again over here. So we have the data loader section, train data loader. Then we also have the batch size. Okay. Cool. So once that is done, we have loaded the data set into the data loader and can iterate through the data set as needed. Each iteration below returns a batch of train features and train labels containing batch size 64 features and labels respectively. Okay, because we specified shuffle equals true, after we iterate over all batches, the data is shuffled. Oh, so the shuffling happens after we have iterated over all the batches, not just like one batch. So the shuffling doesn't happen at each iteration. It happens once all of the stuff has been iterated over. Okay, for finer grained control over the data loading order, take a look at samplers. Okay, we can take a look at that later. For now, let's do the simpler stuff. So train features, train labels equals next. Okay, so we're looking at we're going through the next. Wait, I don't think I've done this with iterators in Python. The thing where you manually do the iteration. I've usually iterated using some kind of mechanism. One of them being for. Let's try that. What does the next thing do? I've used the iter function, but I don't think I've used next. Oh, you know what? While the voice crack, dude. Holy shit. While that's loading, give me a second. Oh, okay. Give me more than a second, I guess, because this is gonna take a little bit. System is being a little slow. Okay. Fuck. I forgot what I was gonna look up. Hold on. Hold on. Hold on, dude. I was gonna look something up. What was I gonna look up? I was just about to look. Oh yeah, Python next. I'm guessing it has something to do with the iterator itself. But like, if you have an iterator, you can then call next on it, right? So you can get like the next iteration. But like, there's something that keeps track of the count of the iterations. I need to look into how that works in Python specifically, because this code here seems to be this code here, it's creating an iteration and then calling next on that iteration. So the iteration is created, or the iterator is created, and then next is called on the iterator. And then that's that. It's just like a one-time thing. Okay, so I need to open up next and iter. Okay, this returns an iterator object. All right. The first argument is interpreted very differently depending on the presence of the second argument. Without a second argument, object must be a collection object which supports the iterable protocol or the iter method, or it must support the sequence protocol, the so-and-so method with integer arguments starting at 0. If it does not support either of these protocols, then type error is raised. If the second argument, sentinel, is given, then object must be a callable object. The iterator created in this case will call object with no arguments for, oh fuck, I missed the add timer. Okay, so that was quick. All right, so add started. I'll see you guys in 30 seconds. All right, welcome back. I also realized that another reason why it might be getting a little bit hard for me to talk and pronounce things and even just get voice out of my throat is because I'm tired. Yep, that is that is definitely one of the reasons. That is also the reason why I didn't stream yesterday. Well, no, why I didn't do a talking stream yesterday. But because I didn't do a talking stream yesterday, I was able. Basically, me not streaming yesterday made it so I was able to stream today. Though, to be fair, it wasn't the fact that I didn't stream yesterday. It was the fact that I kind of pushed the time a little further, because of which I was able to sort of shift my schedule a bit, because of which I had the energy to stream, to do a talking stream today. Cause like if I'm super tired, then I don't really want to do a talking stream in that state. Cause like I'm like talking becomes hard and I'm like slurring my words, and I'll be like confused and shit, and thinking is hard, like my mind is foggy and shit. It's just it's not a good time. It's not a good time to do study streams. It's not a good time to do any kind of research or anything. It is absolutely not a good time for me to be talking, uh, let alone talking on stream. So, like, usually if that's the case, then I just avoid doing a talking stream. I'll do a mute stream in those situations. Okay, next, retrieve the next item from the iterator by calling its next method. If default is given, it is returned if the iterator is exhausted. All right, cool. So this is then basically like calling next, right? So if I say a equals 0, 1, 2, 3, 4, would I then be able to call next? Oh God, don't do the analyzing thing again. Okay, we are waiting. Okay, so there's no next function here. Am I not able to access the next function, or like is there some other issue? What would happen if I do this? Okay, let's try printing out. Okay. Uh, let's not load this massive amount of data. Oh God, dude. Each time I run this, it's taking time to run. I feel like it might be because of this, though there are other reasons why the issue might be occurring, but let me let me just not do this. I don't know if that's somehow causing an issue, but let's see. Okay, okay, okay. There is no next function here. So where exactly, okay, would I then be able to call um, something like this, for example? Okay, I guess not. So I would then need to be able to do, then I would need to do this, and then it would work. Oh, okay. All right, so let's say a iter equals iter a. And then that should show up as, let's hold on. Type a and type a iter. Let's see what shows up. So one is a list and the other is a list iterator. Okay, all right. So if that's the case, now that it's an iterator, I should be able to, nope, that's, oh wait, no, wrong one. So now that this is an iterator, I should be able to call next. Okay. All right. So let's run that again. Okay. Cool. Great. But oh, words. Holy shit. But I don't get how it would be working in a for loop if it's not an iterator. Yeah, I'm confused about that. Like how is it working? You know what? Let me ask Gemini. In Python, how am I able to iterate over a list if it's not an iterator? Oh, iterate over a list using for. Okay, in Python lists are iterable objects, meaning they can be iterated over using a for loop. This is a fundamental feature in Python. This is a fundamental feature of Python lists, and you don't need to convert them to a specific iterator type to use them in a for loop. If Python lists are iterable, no, yeah, are iterable objects, why am I not able to call next on them? That's a great question. While Python lists are iterable, they don't directly implement the iterator protocol. Instead, they implicitly create an iterator object where you iterate over them using a for loop. No, when you iterate over them using a for loop. Okay. All right. Okay. Uh, let's get back to that thing that we were doing, which was uh man, I'm zoning out. Holy shit. Okay, so next iterator, it returns. So when you create an iterator of this data loader, so data loader, okay, so we have data loader. Let's load where is it? Here. Train data loader. Now can we wait, I need to, yeah, there. Now if we are able to create an iterator out of this, would that mean that I'm also able to just access each of, like, you know, the cells? So let's say, what was it called? Train data loader or something? Yeah. Would I be able to do something like this? No. Okay. What do I have access to? I have access to data set. Though how am I able to, okay, so let's say td iter equals no, iter train data loader. And then we do okay, that doesn't work. All right, what if we do next? Okay. All right. So that gave us some data. Okay, cool. Wait, back up. What did this give? Because like that was giving two things, right? The data and the label, which means this also returns two things, doesn't it? This is returning two things. So, okay, data loader. Would I be able to access this without, like, why what actually, okay, the answer for why it's not just accessible like this is probably because the thing hasn't been implemented for it. So I could just do dataset, right? And then dataset should be indexable. There it is. And there's our index. Great. Now, if I did td iter dot next. Okay, let's take a look at how many elements would be returned. It returns 2, which is probably why I'm able to. Okay, how do I td next, I guess. So then let's do td next and print that out. In td next, we have 2 elements. Okay, what if we ran that again? Okay, we have more data. Right, what is the size of the iterator? So let's try to get, it's 938. I think that has something to do with the batch size. Yeah, I think that has something to do with the batch size. Let's try changing the batch size and see if that changes anything here. So let's change the batch size to 512 and see if that made a difference. It did make a difference, but it made the data smaller. That's interesting. Okay, I was not expecting that. I'm not sure what happened there. What was the batch size? 64? I think it was 64. Yeah, I think it was 64. Dude. Okay. I want to keep going, but I'm tired. I'm tired. So I'm just gonna relax for some time and then probably go to sleep after that. Okay. Yeah, I'm not gonna raid anyone. I'm too tired. I'm just gonna relax. That's gonna be it for today's stream. I'll carry on doing this off stream, experimenting and stuff, looking more into data loader. Hopefully by tomorrow, before maybe before tomorrow's stream. Oh wait, this is the end. Okay. Yeah, hopefully before tomorrow's stream, I should be done with data loader. There's a bunch of stuff for me to experiment with in data loader, so I'm probably gonna look at the data loader API as well and see what I'm able to what information I'm able to get from there, and then I'm gonna look into the transforms section as well and see what information I'm able to get here. And then we're going to go into the exciting part, which is building the neural network, where I'm going to have a ton of experimentation to do. Because I want to look into like the different functions that they have, like linear transforms and the activation functions and stuff. I want to look into all of them. I want to play around with a bunch of these things: flatten, sequential, linear, ReLU, and whatever else I'm able to find. But yeah, okay, that's going to be it for today's